So what we're going to be doing today is we're going to be tying everything together that we've learned in the previous two sections, and we're going to start solving trigonometric equations. Now, the preliminary goal in solving trigonometric equations is to isolate the trigonometric function in the equation. Okay, we can also try to reduce them as much as possible, which was the whole point of what we've been doing over the last couple of days. So we're going to jump right into number 17. We're going to solve sine of x plus square root of 2 is equal to negative sine of x. Now we're solving an equation here, so now we can actually go over that equal sign. So what I'm going to do is I'm going to get all of the trig functions on one side of the equation. So to do that, I'm going to add sine of x to both sides here. So now I have 2 sine of x plus the square root of 2 is equal to 0. Okay, then what I'm going to do is I'm actually going to subtract square root of 2 from both sides because we want, again, isolate the trig function. So now we have 2 sine of x is equal to the negative square root of 2. Again, we're trying to isolate the trig value, so we're going to divide both sides by 2. So now we have sine of x is equal to the square root of 2 over 2. Now, what we're going to do here is we're actually going to look in the unit circle. I like to draw mine out. You guys have yours right in front of you. We're going to look for where the y value, because that's what sine is equal to negative root 2 over 2. And it is in two different places. It's down here in the third quadrant, and it's also down here in the fourth quadrant. And that is at x is equal to 225 degrees and 315 degrees. Now notice it doesn't say solve within the unit circle, because usually it says something like 0, theta, 360 degrees, right? Well, that's actually not happening this time. So there are actually an infinite amount of solutions to this problem, not just 225 and 315. Remember that we also have solutions like negative 45 degrees or any of their coterminal angles. So just to make sure that we have all solutions that are possible here, we're going to add plus or minus n 360 degrees. And this is just telling us we know that it's 225 degrees and 315 degrees, but we also understand that it's all of their coterminal angles are also going to be the solutions here. Okay, so very important. So if it says this up in the top, if it says between 0 and 360, you could stop with just the two numbers, but because it doesn't actually say that here, I want this plus or minus n 360 degrees. And obviously, if we were doing this in radians, you could have n 2 pi. Okay, so let's look at number 18. So we have solve 2 cosine squared x minus 1 is equal to 0. So what we're going to do first is we're going to add 1 to both sides because we want to isolate the trigonometric function. So we have 2 cosine squared x is equal to 1. Again, we're going to try to get out that cosine all by itself, so we're going to divide both sides by 2. So now we have cosine squared x is equal to 1/2. Now I'm going to square root both sides because I want to get rid of this square. So now I have cosine of x is equal to plus or minus, don't forget that when you take the square root of something, it's plus or minus, the square root of 1 over the square root of 2, which is going to rationalize after we multiply the top and bottom by the square root of 2 over root 2. It's going to be plus or minus root 2 over 2. So we're trying to look in where in the unit circle cosine, or the x value, is equal to positive or negative root 2 over 2. So if I'm looking at my unit circle, I know that it's at all of these angles right here. So we have x is equal to 45 degrees, 135 degrees, 225 degrees, 315 degrees, but don't forget it's not just these four angles, it's all of these angles, coterminal angles as well. So we don't just have 4 answers, we have an infinite amount of answers. You can add 360 or subtract 360 from any one of these angles to find another one. Okay, so I think we're starting to get the hang of it a little bit here. Let's go down to something we actually need to start using our identities for. So here we have cotangent of x times cosine squared x is equal to cotangent x. So I want to get all the trig identities on one side of the equation. So what I'm actually going to do is I'm going to subtract cotangent of x from both sides. So now I have cotangent of x times cosine squared x minus cotangent x is equal to 0. Okay, Now we're going to try to simplify this using our simplifying trig identities rules. So the first thing we need to look for is something we can factor. And if you look, both of these terms has a cotangent. So what I'm going to do is I'm actually going to factor out a cotangent of x. So cotangent of x times cosine squared x minus 1 is equal to 0. Okay, so now I have two things that are multiplied together to equal 0. Now there's a really cool rule called the zero product property, which says if you have two things that are multiplied together and they equal 0, you can actually set each of those products equal to 0 as well. So that means that we can set cotangent of x equal to 0, and we can also set cosine squared x minus 1 equal to 0. So now we kind of separated this into two separate equations, and will actually make it easier for us to solve. So we need to look at the unit circle and see where cotangent of x is equal to 0. So we know that cotangent is equal to x over y, or 1 over tangent, whatever one that you need to think of when you're doing this. So when you look at the unit circle, okay, you'll see that cotangent is equal to 0 here at 90 degrees and also here at 270. So we have x is equal to 90 degrees and 270 degrees, but again, we cannot forget all of their coterminal angles. So we're going to have n times 360 degrees. Okay, so that's one part of the equation. That's some of the answers. But now we also have to look at this cosine squared x minus 1. Okay, so what we're going to do is we're going to try to isolate the cosine all by itself. Okay, so what we're going to do is we're going to add 1 to both sides. And I'm starting to write smaller because I realize I only have so much space here. So you have cosine squared x is equal to positive 1. We're going to take the square root of both sides. So now we have cosine of x is equal to plus or minus 1. Okay, so what we're going to do is we're going to look at our unit circle again. Okay, please don't throw that unit circle out. It's going to be super important. And we know that x, or cosine, is equal to 0 at two places, here at 0 degrees and here at 180 degrees. So we have x is equal to 0 degrees, 180 degrees, and don't forget all of their possible coterminal angles. So here's the full answer: 90 degrees, 270 degrees, 0 degrees, 180 degrees, and all their coterminal angles. Okay, so we're starting to pick it up a little bit. In number 20, we have solve tangent squared x plus 2 tangent x is equal to negative 1. So what we're going to do is we're going to get everything on one side, because I don't know if you guys see this, but there's going to be something factorable here. So I'm going to add 1 to both sides and see what that does. So now I have tangent squared x plus 2 tangent x plus 1 is equal to 0. Okay, so remember that when we were doing some other problems, we did something like this. Instead of tangents, we turned these into x's just for a moment, so you guys can see where the factoring is going to come here. So if we had x squared plus 2x plus 1, we know that this would just factor into x plus 1 times x plus 1. So what we're going to do is we're going to take that knowledge, okay, and we're going to see that this is going to factor into tan x plus 1 times tan x plus 1, which are the same thing. So either one of these has to be equal to 0. So we have tangent of x plus 1 is equal to 0. We're going to subtract 1 from both sides. Now we have tangent of x is equal to negative 1. And if we look at our handy-dandy unit circle again, pretty sure you guys are sick of me saying handy-dandy, we can see that at 135 degrees and 315 degrees, our tangent is equal to negative 1. So x is equal to 135 degrees, 315 degrees, and we cannot forget all of their coterminal angles. So for example number 21, we have solve 2 sine squared x plus 3 cosine x minus 3 is equal to 0. Now we have a problem here, because we want to be able to factor things here. I think we have 3 terms, and usually you think factor when you have 3 terms, but we don't have the same trig here and here. But what we do have is our Pythagorean identities. So what I'm going to do is, in order to make them all the same trig function of cosine, I'm going to turn sine squared x into 1 minus cosine squared x. So we have 2 times 1 minus cosine squared x plus 3 cosine x minus 3 is equal to 0. And again, I just want to point out that we used Pythagorean identity here to go from sine squared x to this guy in the parenthesis. So now what we're going to do is we're going to distribute this 2. So we have 2 times 1 is equal to 2. 2 times negative cosine squared is negative 2 cosine squared x plus 3 cosine x minus 3 is equal to 0. And then what we can do is we can now reduce these guys right here because 2 minus 3 is just negative 1. So now we have negative 2 cosine squared x plus 3 cosine x minus 1 is equal to 0. So how we're actually going to solve this is something called factoring by grouping. Now, I know you guys are looking at this and going, wait, there aren't 4 terms here. What we're actually going to do is we're going to split up this middle term into 2 separate terms. And you get better at this the more you do. So what I'm going to do is I'm going to break that 3 cosine x up into 2 cosine x plus cosine x, because 2 cosine plus 1 cosine, 3 cosine x minus 1 is equal to 0. What I'm going to do is I'm going to factor by grouping here. I'm going to pull something out of here. We have negative 2 cosine squared x plus 2 cosine x. I'm going to pull out a negative 2, and then I'm up to negative 2 cosine of x, and then I'm going to be left with cosine of x minus 1. And then if you look here, I have a cosine x minus 1 in my parentheses, so the only thing I can pull out there is actually just a 1. So we have cosine of x minus 1 is equal to 0. So then I'm gonna factor this now that I have a cosine minus x in each category. So now I have negative 2 cosine of x plus 1 times cosine of x minus 1 is equal to 0. You guys could also use your factor trees and your x's. Somebody called it an ABC rule the other day, but you can use whatever factoring method you want. You could also have turned all of these guys right here into x's. You could have done negative 2x squared plus 3x minus 1. You could have factored that way. Again, I'm not telling you guys which way. You have to do whatever one you're more comfortable with. I like factoring by grouping because you can actually never really mess that up. So now that we have 2 of these things multiplied by each other is equal to 0, we can also use the zero product property again. So that tells us that we have negative 2 cosine of x plus 1 is equal to 0, and it also tells us that cosine of x minus 1 is equal to 0. So now we're going to solve each one of these for cosine. So we're going to subtract 1 from both sides here. Again, I'm running out of room, so I apologize if I'm writing a little small. Then we're going to divide both sides by negative 2. So we're looking for where cosine of x is equal to 1/2. And in the unit circle, cosine of x is equal to 1/2 at 60 degrees and 300 degrees. And we cannot forget all of their other answers here. Okay, so then we also have cosine of x minus 1 is equal to 0. So we're going to have cosine of x is equal to 1 after we add 1 to both sides. And cosine of x is only equal to 1 in one place, and that is at 0 degrees. So x here is equal to 0 degrees, and we cannot forget all of their coterminal angles. So here is the answer for this entire function. Again, I'm really sorry that we had to squish it in there. Okay, so we have one more problem, and it's a little bit different. We're going to use a method called substitution here. We have 2 cosine of 3t minus 1 is equal to 0. So the first thing I'm going to do is I'm going to get the cosine all by itself. Okay, so I'm going to add 1 to both sides. So now we have 2 cosine of 3t is equal to 1. I'm going to divide both sides by 2. So now we have cosine of 3t is equal to 1/2. Now here's where it gets a little tricky. By tricky, I mean cool. Okay, we're not going to think of this 3t anymore as one thing. We're going to think of it as a star, because stars are easy for me to draw. Okay, so we're going to go off in a little bubble zone here. So instead of cosine of 3t, we're going to have cosine of a star is equal to 1/2. You could use any other variable. You don't have to use a star. Okay, so if you look in the unit circle, you know that cosine is equal to 1/2 in two places. Okay, it would be at 60 degrees and at 300 degrees. Now, knowing this information, we know that star is equal to 60 degrees and 300 degrees, but it's not really a star, it's really a 3t. So we know that 3t is equal to 60 degrees, and we also know that 3t is equal to 300 degrees. So in order to find t, we're going to divide both sides by 3 to get 20 degrees, and we're going to divide t here by 3 to get 100 degrees. Now, to find all their coterminal angles, it's just a little bit different, okay? You're going to actually do n times 360 divided by whatever number is being multiplied in front of that t. So in this case, it's 3. So it's going to be plus or minus n times 120 degrees. So here are all of our answers. Okay, so it's a little bit tricky. You only have a couple of these to do, and we will learn things in the future to be able to break that 3t apart if you don't want to do this method. So that actually concludes today's notes. I know that there was a lot, and right now you're going to practice. And if you guys need help or anything else, I am in the Google Meet. I'm also available through the GoGuardian chat and email, although it's the best way to reach me for questions on this during class is in the Google Meet, because you guys know I can show you what's going on. Okay, so again, I'm in the Google Meet. I hope you guys have a fantastic day.